Assalamu alaikum, my dear student. I welcome to my chemistry class where we are gonna discuss salt analysis. What exactly salt analysis is? To know an unknown salt, right? Or to identify a given salt. As we all know that salt is an ionic compound which is the combination of a cation and an ion. For instance, the salt is sodium chloride, so sodium is the cation of the salt and chloride is the anion of the salt. Okay, so what exactly we do in salt analysis? It is a qualitative analysis in which we do some test to know which cation is present in the salt as well as which anion. So once we knew the cation and anion of the salt after going through some test, some chemical reactions, so we would be able to identify the salt. For example, sodium chloride, copper sulfate, copper nitrate or something like that. Okay. So first of all, to know if the salt is hydrated. If the salt is hydrated, what we do, let us share a picture. If a salt is hydrated, so what we do, we take the solid sample of the salt and we heat it and cover the test tube with a lid, not allowed for the water particles if the salt contains to escape. Okay, so after heating, we cool down the test tube and we will observe some droplets inside the test tube, which is the evidence that the salt is hydrated. Otherwise, salt is anhydrous. Some of the cations can be identified in the solid state. All right. So what we do, we go through flame test. We perform some flame test on solid salt to know which cation the salt contains. So what we do exactly, what was the procedure we adopt? We take a nichrome wire, a loop of nichrome wire, and we purify it, putting in acid and then taking it to the flame just to sterilize or purify the nichrome wire. Okay. And then we dip the loop of the nichrome wire into the solid salt and take the loop to the edge of the flame. According to the cation present, the flame changes its color. So let's look at the different colors, which are the evidence of different cations. So if the salt contains barium ion, it will be apple green. The color of the flame will be apple green. If group 2 ion strontium is present in the salt, so it will give a color crimson, which is near to red. If the salt contains lithium, it will be red and the flame color will be yellow if sodium ion is present in the salt, and sea green in the case of copper, and potassium gives lilac color. If these ions are present in the salt, so they can straight away be found out by doing flame test on solid salt. Right. So, but many ions like transition metal ions cannot be identified by flame test. So what we do basically, we dissolve the salt to make its aqueous solution, and then when we do some test adding reagents to find out those cations using aqueous solution. So the sample of aqueous solution of the salt is taken in a different test tube. So first of all, we are going to find out zinc. zinc, aluminium, and calcium. Why we are considering? Because when sodium hydroxide is added to the given salt, if these ions are present, so they give white precipitate. So white precipitate is actually for the ion, it combines with hydroxide ion present in sodium hydroxide, aqueous solution of sodium hydroxide, or aqueous solution of ammonia. It is rich with hydroxide ion, so hydroxide ion reacts with the cation present to form an insoluble hydroxides of those metals. Right, so this insoluble hydroxide appears as white precipitate. Okay, we use sodium hydroxide in excess to see whether these insoluble salts are soluble in excess or not. So we find zinc is soluble and aluminium is also soluble. So up till now, after using sodium hydroxide, we are not sure whether your salt contains zinc or aluminium, but when you go ahead for third and fourth step, so we'll be able to know that white precipitate will again be the result, and in excess of ammonia, zinc is soluble, but aluminium is insoluble. So here, if this precipitates are insoluble, so we will say aluminium is there or present in the salt. If it is soluble, so we will say that zinc is present. Okay, so if calcium is there in excess of sodium hydroxide, white precipitates of calcium is insoluble, so it makes calcium distinguished from zinc and aluminium. In ammonia, it gives very few precipitates, or no precipitate, right? So what happens basically, aluminium reacts with hydroxide to form aluminium hydroxide, and calcium reacts with hydroxide to form calcium hydroxide. So these are basically insoluble hydroxides which appear as white precipitates, and when we add excess sodium hydroxide, so two of them are soluble and calcium is insoluble, and two of them which are soluble will be distinguished when we add ammonia as reagents, first dropwise and then in excess. Right, so moving on, copper now. As I'm using blue color, so we can say that copper ions give out blue precipitate when we add few drops of sodium hydroxide, right? And when we add in excess, it remains insoluble in excess of sodium hydroxide. And when we will cross check with ammonia dropwise, so it will give the same result, blue precipitate, but in ammonia it is soluble to give deep blue solution, deep blue solution, right? So what is the reaction? Copper ion present in the salt combines chemically with hydroxides present in these alkaline solution to form insoluble copper hydroxide, which appears as blue precipitate, and then we add sodium hydroxide in excess to see the solubility of the precipitates. Then chromium. Chromium, it gives green precipitate. Green precipitate. So we are adding chromium and Fe2 plus Rn2. So they both give green precipitate when we add sodium hydroxide dropwise. So chromium, and what is the difference between chromium and iron? We get it in very next step, because chromium is soluble to give green color solution in excess of sodium hydroxide, whereas Rn2 is insoluble. Right. So here we got the difference between chromium and Rn2 giving green precipitate. One is soluble and the other is insoluble in excess of sodium hydroxide. So cross-checking, you will get the same results with chromium, that green precipitates and insoluble in excess. With Rn2, when we add ammonia dropwise in excess, it gives the same result as the chromium with ammonia. Green precipitate, insoluble. So basically these green precipitates are chromium hydroxide and iron hydroxide respectively. So chromium reacts with hydroxide to form chromium hydroxide, insoluble salt, and Rn2 also reacts with hydroxide to form Rn2 hydroxide. Lastly, Rn3. Rn3. It gives a red-brown precipitate. Red-brown precipitate, insoluble in excess. Red-brown precipitate when we add ammonia. Insoluble. So the color is the only difference between Rn2 and Rn3. Green precipitate with Rn2 and red-brown precipitate with Rn3. They both are insoluble in the excess of both the alkaline solution. So what is the red-brown precipitate for? They are Rn3 hydroxide. Rn3 hydroxide. Okay, so now moving on to the anion. So coming to the identification of anion, so first of all, carbonate, and we have to choose a suitable reagent. When we add the reagent to carbonate, it gives out such product which can be observed easily. So, and we know that carbonate, when it is added to an acid, it produces carbon dioxide, which can be observed easily as effervescence and fizzing. So a dilute acid would be the appropriate reagent for identifying carbonate in the salt. So what happens basically, H ion of the acid reacts with carbonate if the salt contains carbonate it forms water and carbon dioxide. So carbon dioxide is observed as fizzing or effervescence, right? If you are asked to test the gas produced, obviously you will go for lime water test, which turns cloudy. But if it is asked, right? So next, halides. Halides may be chloride, bromide, or iodide, right? So what we do exactly, so using halide, what kind of product we can make which is observed easily. So you know that gases and insoluble salts and color changes are observed easily during a chemical reaction. So we should think whether we can produce or we can make insoluble salts using these. Yes. So if we have silver reagent containing silver, so silver can react with chloride, bromide, iodide to form silver chloride, silver bromide, and silver iodide respectively, which are insoluble salts and are observed as precipitates. Okay, so acidified means adding acid. Acidified silver nitrate will be the best reagent. So what happens? Silver nitrate reacts with chloride, bromide, or iodide to form insoluble salts of silver chloride, which appears as white precipitate, and silver bromide, which appears as cream precipitate, and silver iodide, which appears as yellow precipitate. All right. Coming to sulfate, with 2 negative charge. So we know that which kind of or which sulfate salt would be insoluble. So we know that barium sulfate is insoluble. So what we do, basically acidified barium soluble salt can be taken as the appropriate reagent for sulfate to trap from the solution, right? So acidified barium nitrate or barium chloride will be the best reagent to trap sulfate from the solution. So barium will combine with sulfate if the salt contains it to form insoluble salt of barium sulfate, and which appears as white precipitate. All right. Lastly, sulfite with 2 negative charge. When we add an acid in sulfide, a dilute acid like nitric acid or hydrochloric acid, so what happens? Basically it forms sulfur dioxide gas, hydrogen plus sulfite, it forms sulfur dioxide gas with water. All right. So when sulfur dioxide gas is formed, so we can easily identify the presence of sulfite by doing the test for sulfur dioxide gas. And what is the test for sulfur dioxide gas? If your test tube is containing is having sulfur dioxide, so we just add an acidified oxidizing agent, acidified KMNO4. So purple color of KMNO4 will go off. It will go colorless. So the change will be observed. The purple color of KMNO4 will turn colorless. So it will only turn colorless with sulfur dioxide present, which is oxidized by this oxidizing agent to turn. So sulfur dioxide, basically it is oxidized to sulfur trioxide, and when KMNO4 oxidizes sulfur dioxide, it is reduced itself and its color loses. Okay, so this is the observation, which is the evidence of sulfur dioxide gas in the test tube. And sulfur dioxide gas is only produced when the salt contains sulfur trioxide. So I hope you find this video useful. Share with your friends and subscribe to the channel to get like videos. So till the next video, take care. Wassalamu alaikum wa rahmatullahi wa barakatuh.